Johnny here with Simpson Math. In this video, we'll be solving logarithmic equations. I have an example here. I want to solve log base 3 of x plus 2 equals negative 4. The very first step is to worry about the domain of our equation, of our function here. Remember, logarithms have a restricted domain, like the even roots, where we cannot take the square root of a negative number, like the rational functions, we cannot divide by 0. Logarithms, their arguments have to be positive. In pink, I have sketched out a logarithm graph, and something similar to what we've done in a previous video. And the domain here is starting on the positive side of 0 up to infinity. So the domain is all the positive numbers. So when I go off to find the solutions to a logarithmic equation, the very first thing I need to do is worry and concern myself with the domain. So I'm going to find the domain of this logarithm. Now to do that, the argument must be positive. So to find the domain, I'm going to set the argument greater than 0 and solve. Whatever's inside my parentheses, x plus 2, we call that the argument. It has to be positive. Solving this domain will be all values bigger than negative 2. So it's like I took my logarithm graph and I shifted left 2 units. Some sort of transformation happened there. But I know my domain. I can only plug in values bigger than negative 2. So that way, or that means at the end, when I think I have the solutions, if one of my solutions is negative 5, well, negative 5 is smaller than negative 2. So that would not work. It's got to be bigger than negative 2. All right, first step taken care of. I've talked about domain. Second step. In a logarithmic equation, I like to state the domain, and then similar to solving exponential equations, in solving logarithmic equations, I want to isolate the logarithm. So if it has some sort of coefficient or like a plus 2 on that same side of the equation, I want to make that go away. But this logarithm seems to be isolated, all by itself. Next, I'm going to rewrite it in exponential form. So I'm trying to answer the question, what can I plug in for x to make this equation true? And I mean, I could do some trial and error, but I don't think that's going to work. So I'm going to take this logarithm and rewrite it as an exponential, using the definition of logarithm. So I know the definition. I take my base, 3, I raise it to the other side of the equation, negative 4, and that will equal the argument of my log, x plus 2. Just using the definition of log to take exponentials to rewrite them to logarithms, or logarithms and rewrite them as exponentials. Now I can simplify on the left. A negative exponent, we reciprocate the base. So this becomes 1/3 to the 4th power. And 1 to the 4th power is still 1. So I'm just needing to raise the 3 to the 4th power. So I have 1 over 81 equals x plus 2. Trying to get the x by itself, I will subtract 2 from both sides. I'm looking at the answer. Maybe I could simplify this. Yeah, so 81 doubled is 162. So I'm going to get a common denominator. Now, before I box my answer, I have to double check every time. no matter how easy you think it was. You've got to check your proposed solution with the domain restriction. We said our answer has to be bigger than -2. So I can, on a number line, put down -2. And I'm talking about all these values. Now, -161 divided by 81, that's not simplifiable, but -160 or 162 over 81, that is 2. So if I take a little bit and subtract 2 from it, so here's maybe 0. If I start at a very small number, 181ths, very small number, and subtract 2, I'll still be on the right-hand side of -2. So this is definitely bigger than -2. It's closer, like it's on that side. So this works. Hopefully the next examples are more obvious, but this is greater than -2, so therefore this is my solution. I went through these steps. I worried about the domain. I isolated the log, rewrote it as an exponential. I was able to solve it just by subtracting 2 from both sides. Then I checked my answer. Once I was happy with it, I boxed my answer. We're going to do that a few more times just to get down this solving logarithm equations process. Let's try this one. 6 times the natural log of a -2x is equal to 30. We call this type of equation a logarithmic equation because the unknown variable is inside the argument of the logarithm. Before I can even begin with this problem, I need to worry about domain. The argument of the log has to be greater than 0. I'm going to say that in math symbols. -2x must be greater than 0. I can solve for x dividing both sides by a -2. Oh, now that's tricky because, make sure that correctly. Yeah. Because when I divide by an inequality by a negative, it's going to swap the inequality. So this is actually going to be x is less than 0. I'm just going to draw a number line just for my own sanity. If there's 0, then we're talking about everything smaller than that. Not including it, but everything smaller. So in the end, whatever my answer is, it better be less than 0. All right. Next, I need to isolate the logarithm. So right now, it has a coefficient of 6 that needs to be divided off. "30 divided by 6 is 5. I've isolated the logarithm. Now it is safe to rewrite it in exponential form. So I have e to the 5th power is equal to the argument -2x, just using the definition of a logarithm to rewrite a logarithm in exponential form. I'm almost done. To solve for x, I divide both sides by -2. X is equal to e to the 5th power divided by a -2. I'm not sure what that value is, but all I really care about is this number less than 0? Well, it's negative, so yes. I can box it and be done. Now, before I move on to another example, this is how I would solve a logarithmic equation. This is how I tell my students to do it, how I show all my work. But there is another skill that may come in handy, And right now is about the time to talk about it. So I'm going to work that problem again. I'll do it in green just to change things up. 6 ln neg 2x equaling 30. It's the same idea. You still have to worry about the domain x is less than 0. You still have to isolate the logarithm. So I'm going to divide both sides by 6. But here's a skill that we should maybe try to practice. It is legal, mathematically legal, to take both sides of the equation and treat them as exponents of the same base. So I could say 3 to the left-hand side as a power is equal to 3 to the 5th power. I can create whatever base I want to be down there and treat these as exponents. Now, it would be strategic to choose e as my base because I have this natural log base e on the left-hand side. I'm going to do that. I'm going to say on the left-hand side, I have e being raised to this power equaling e being raised to the 5th power. This is this legal maneuver in math. We use it for various types of problems. It's not required for logarithmic equations, but it can be very helpful because now on the left-hand side, I see that my bases are matching. This is one of those inverse properties of logarithms we have talked about. This will just, in the end, simplify to negative 2x. And like the previous example, the previous option of how to work this problem, I can quickly solve for x by dividing both sides by negative 2, and I get back to where I was before. So there's maybe another option to solve logarithmic equations. Instead of rewriting an exponential form, what you can do is create exponents. So come up with a smart base and raise that base to the left and right-hand side of the equation. All right, I'm going to stick with my steps, though, written on the board, just for understanding. All right, let's try another example. Let's do log base 6 of x plus 5 plus log base 6 of x equals 2. Oh goodness. I'm super concerned because now all of a sudden I've got 2 domains to worry about. In fact, I need to worry about it. The domain of this first one, x plus 5, that argument, has to be greater than 0. This logarithm has its own problem. X has to be greater than 0. I'll solve the first domain for x, so x has to be greater than negative 5. Now, these have to agree. I can't, if this says I can plug in numbers like negative 1, but over here when I try to plug in a negative 1, I get nonsense, the negative 1 doesn't make any sense. So these 2 restrictions, or these 2 domains, have to agree. So it may be helpful to put them both on a number line and just make sure they both agree. So negative 5 seems to be important, 0 seems to be important. The first one I'll do in pink, it's every number not negative 5 but bigger. The second one I'll do in a different color, it's every number not 0 but bigger than 0. Okay, so if I try to plug in negative 2, it will work for the first one but not the second. So the green one seems to be a little bit more strict. I'm going to go with it. the domain for this scenario is it has to be bigger than 0. So if you're given multiple logarithms, you need to find the domain of all of them and then figure out where they agree. If one is more strict than the other, then that's going to be the one you go with. This one, I say it's more strict because it doesn't include some of these negatives. All right, stated the domain. I'm now ready to isolate the logarithm. Well, wait a second. I have 2 logarithms. How am I supposed to isolate the logarithm? Oh, right. If you have 2 logarithms that happen to have the same base and you're adding them, log plus log, the sum of 2 logs can be rewritten as a single logarithm. I'm going to condense these. Step 2, I'm condensing the logarithms. A single log base 6 of, because I'm adding, I will be multiplying my 2 arguments. X plus 5 times x. I used my exponent properties to condense those 2 logarithms into a single logarithm. I have isolated my logarithm. I think it's now safe to apply the definition. 6 to the 2nd power will equal my argument. I think I'll multiply out my argument. I'll distribute. X times x plus 5 is x squared plus 5x. All of a sudden, I have left the logarithm equation behind. What type of equation is this? This is quadratic. To solve a quadratic equation, we set one side of the equation equal to 0, and we just hope that this thing will factor. So I'm going to do that. I'll subtract the 36 over. Setting the equation equal to 0. I'm now trying to solve a quadratic equation. Lots of options. There's a formula, complete the square, but I'm hopefully going to be able to factor this. The factor of a trinomial should factor into the product of 2 binomials. X and x will give me x squared. Factors of 36 that also sum to 5. 9 and 4 will do it. They need to be opposite signs to give me a negative 36, but they need to add to a positive 5. I'm thinking positive 9 and negative 4. I can set each factor equal to 0. So I get x equals 4 and x equals negative 9. Box my answers and I'm done. Hold on. Negative 9 is not in any of those domains. This one is way too low. I'm going to have to discard that solution. It's extraneous. It doesn't make any sense here. I'm checking my proposed solutions versus the domain. One of my solutions doesn't make sense. It's not in my domain, so I can't include it. I can only box 4. 4 is the only solution to this equation. Let's do it again. Involve it. All right, this is very similar to the one we just did. In fact, I kind of want you to pause the video and try it real quick. I will then, you can check your answer with mine. So yeah, pause and see if you get the same thing I did. Waiting for you to pause again. 2 is in my domain. It's bigger than 1. So I'm totally on board with just boxing my answer. X equals 2 is my solution. Fun. All right, I got maybe one more problem. I'll make it as tricky as I can. If you can do this problem, then you can do all of the homework that I give you. So let's try it. We've got log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 all equal to 2. So conveniently, all these logs have the same base, meaning I could probably condense them in a second. But before I do any of that, I should really concern myself with the domain. The first one, x minus 3 has to be bigger than 0, so x has to be bigger than 3. The second one, x has to be bigger than 0. Okay, well yeah, that's more strict. Wait, I'm confused. The next one, x plus 2 has to be bigger than 0, so x has to be bigger than negative 2. I was having some mental problems right there, so I'm going to put these numbers on a number line and just see which one's more strict. I have 0, I have -2, and I have 3. The first one says everything bigger than 3. The second one says everything bigger than 0. That doesn't make any sense. The last one says everything bigger than -2. So I think the very first one was the most strict. -1 would be okay for x is greater than -2, but it wouldn't work for the other two. +1 would work for those two, but not that one. So I need all the values that are bigger than +3. First step is to state the domain. I'm going to state the domain as 3 to infinity. If I get multiple solutions, they better be bigger than 3. All right. Then I'm supposed to isolate the logarithm. I've got 3 running around, but I know my product and quotient properties. In fact, I feel so confident that I'm just going to do this in one step. In the previous video, I would have applied the product rule, the product property first, and then the quotient property. I'm going to do it all together. I can tell I'm going to have log base 2 of, these two will be in the numerator, x times x minus 3. That's being divided by this argument, x plus 2. I did a lot there, but if you have any questions, please see the log properties video. All right, I've isolated this thing, so I can now rewrite it in exponential form, just using the definition of a logarithm. This is 2 to the second power equaling my argument. I think I'll distribute in this step as well, calling this x squared minus 3x over x plus 2. Now I'm in this solve step. Maybe not obvious what to do, but I don't like that denominator, so I'm going to multiply both sides of the equation by x plus 2. That will reduce it on the right, and just move it over to the left. I'm also going to call 2 squared 4 and distribute. So I have 4x plus 8 on the left-hand side. I no longer have a rational equation. I no longer have a logarithmic equation. I now have a quadratic equation. These are fun to solve if you can set it to 0 and factor it. So I'm going to move the 4x to the right the 8 to the right. I'm going to set this thing equal to 0. This should factor. Factors of 8 that sum to 7 will be 1 and 8. The signs need to be different, and the bigger one is negative. So now I can set each factor equal to 0. And I have two solutions. X equals -1 and x equals +8. Two proposed solutions. I just need to double check now that these values are bigger than 3. Ooh, not the case. X equaling -1 wants to work, but I have to discard it. That is not in the domain of my original setup. So I can't even talk about -1. I can only talk about numbers bigger than 3. So this one, x equals 8, is my solution. All right, that's just kind of an introduction to solving logarithmic equations. I hope that helped, and I'll see you in the next video.